everyone, this is Erica Hathaway and we're going to be doing Physics C, number 59 from chapter 11. Alright, so while this is a red problem, it looks hard, but it's actually really simple. So the first part, we're going to first draw a picture, which is basically a disk, which we want to get into pure rolling motion. So part A asks us to find the time it takes to reach pure rolling motion. I abbreviated that as PRM. Alright, so we know that the change in momentum equals force times change in time, which also equals mass times change in velocity. We also know that the velocity equals r omega, so we're going to plug that in. And keep in mind that the only force there is friction. So we're going to plug that in and say force times change in time equals mr omega. And then you're going to solve it. And remember, friction is UFN, which is normal force is mg. Then we're going to plug that in, cross out the m's, and you're going to get change in time equals r omega over coefficient of friction times gravity. See? That was pretty easy. Alright, part 2 asks us to find the distance traveled until we reach pure rolling motion. So we're going to use the conservation of angular momentum to figure out omega, which is angular velocity, and then we're going to use that to find, you're going to use work to find the distance. So we know that this is the momentum conserved, angular momentum conserved, and then keep in mind WO equals initial angular velocity, and then the other W is the final. All right, so we're going to plug that in. This is for a disk. This is I for the disk, 1/2 mr squared. And then we're going to try to solve for this W right here, which, if we solve and do all the algebra, it's going to equal 1/3 angular velocity initial. Work is change in kinetic energy, which also equals 1/2 mr squared. We're going to remember later that work also equals force times change in x. So we're going to solve, we're going to plug all the thingies that we found up here into 1/2 mr squared. So remember that it's not 1/2 mr squared. This is v squared. Right? And then we know that v is r omega. So we're going to plug that in, 1/2. And then we're going to plug in the w for the 1/3 omega initial, which is going to equal 118 mr squared over mr squared angular momentum initial squared. And then we also know that it's force, which the only force is friction, times change in x. And we're going to solve for change in x, which if you simplify, you get this, cross out the m's, masses, and you get change in x equals r squared w initial, angular momentum initial squared, angular velocity initial squared over 18 coefficient of friction times gravity. Good job!